So yesterday's geometrical construction, I didn't get any response. Whether you are writing the steps, whether you understood. Try to get up your answers, okay? So that I can easily move to the next question. Clear? So now yesterday we were doing construction of a tangent, a pair of tangent in different conditions. Okay? Today also we go with the assignment what I given, worksheet what I given. According to that, construction of tangents. Have you all tried the first question of the worksheet? Draw a line segment of length 7 cm. Divide it in the ratio 3:5. Have you all done? Even second question also, yesterday I have done the same type. Is anybody tried those questions? Question number 3, question number 4, question number 5. Up to that, yesterday only I have discussed. First question, division of line segment. Second question, division of line segment. Third question, construction of a tangent to a circle from a given point P. Then pair of tangents to a circle of radius, and then another pair of tangents at a distance of from a point. Draw a tangent to a circle. Draw a pair. Fifth question, take the corrected form. Draw a pair of tangents to a circle of radius 4.2 cm from a point P at a distance of 10 cm from its center. Now I will go with the sixth question of your worksheet. Till 1 to 5 I discussed the type yesterday. Now sixth question is different type. Okay? Take the question. Draw a circle of radius 4 cm. Draw a circle of radius 4 cm. Then you have to construct tangents at an angle of 60 degree. So I will give the rough figure here how to construct, then I will do the construction. The rough figure shows, first you have to draw a circle of radius 4 cm with center O. Now draw an imaginary diameter here AB. Okay. Now using your compass, construct 120 degree, 60, 120 degree and name it as A. Why I am constructing 120 degree? This is another property of the tangent. They make supplementary angles. That is, I will show you first the rough figure of construction. This is the point P which has an inclination of 60 degree. When they mention the inclination is 60 degree, here I constructed 120 degree because there is a relation angle subtended by the tangent at the point of contact to the external point here. They are supplementary. When it is 60 degree given, the other angle will be 180 minus 60, it is 120 degree. So without any distance, here we construct 120 degree, 120 degree, and after constructing the perpendicular lines at point A and B, you will get the point of intersection, that is 60 degree. Okay, na? So this is a rough figure I have given, rough figure. Now I will give the steps of construction, complete the steps of construction, then I will do the construction. Okay. Step 1. Draw a circle of radius 4 centimeter. Second step. At O, construct 120 degree such that angle AOB equals 120 degree. In the bracket you write 180 minus 60 equals 120 degree. Next, at point A and B, construct perpendicular lines intersecting at point P. Now, angle APB equals 60 degree. That is, it is making 60 degree with the tangents. These are the two tangents making 60 degree. When the question it is 60 degree, here I constructed 180 minus 60, 120 degree. Suppose here it is 45 degree, we must construct here 135 degree. Suppose if it is 90 degree, here we should construct 90 degree. Okay, na? Don't consider it is the double we are constructing. This is the property which satisfies sum of the angles bounded between the radius drawn to the point of contact and to the external point is always supplementary. Holding that property, we have constructed. We are going to construct. This is a rough figure I am showing, and here this is the steps of construction. I will read the question. Steps of construction. Draw a circle of radius 4 centimeter. At O, construct 120 degrees such that angle AOB equals 120 degree. Next, at points A and B, construct perpendicular lines intersecting at point P. Now, angle APB equals 60 degree, where PA and PB are tangents. PA and PB are tangents. Is this okay? Shall I start the construction now? This is about the steps of construction. I will show you how to get the construction. This is the rough figure I am showing. This is the steps of construction. Now we will do construction part. Let us start. Take your compass having the radius 4 centimeter. 4 centimeter from here. Draw a circle of radius 4 centimeter using your compass like this. Okay. Now, passing through the center, make one dotted line so that we can construct 120 degree here. How to construct 120 degree? Constructing 60 degree 2 times, 60 plus 60, 120 degree. So keeping your compass here, construct 60 degree plus 60 degree. It is 120 degree. Now, passing through that R, name the point as A and B. That is, after drawing a circle of radius 4 centimeter, first draw an imaginary diameter and with O as center, with convenient radius, draw an arc. Now same radius, if you cut off, you will get 60 degree. Double click, you will get 120 degree, 60 plus 60. Now passing through that arc, if you draw OA and OB, so that angle AOB is 120 degree. Till that everybody understood? Shall I move on to the next stage? Have you all understood now? Okay. Now at point A and B we have to construct 90 degree perpendicular, because to construct the tangent it should satisfy the radius drawn from the point of contact is perpendicular to the tangent. It is another property of the tangent. So to obtain the tangent here, A and B we do perpendicular line. I hope you know the perpendicular line construction. With convenient radius, draw an arc, same radius. If you cut off 60 plus 60, and in between if you cut off, you will get 90 degree line like this. So now passing through the intersected arc, you will get a line like this. Okay. Now at point A also you have to construct the 90 degree, draw arc. Those who are not able to follow, plus here observe it. See, this is an arc, cutting 60 degree, 60 degree, bisecting 30 degree, you will get 90 degree. Now passing through that, you draw an arc here. Point B, so you can again check it. You check it, you will get 90 degree here. 60 degree, not 90 degree, 60 degree. This is how we construct tangents with an inclination of 60 degree, right up 60 degree here. This is the construction with the inclination of 60 degree, satisfying the property of the tangent to a circle. The sum of the angles bounded is always supplementary, satisfying that property. Clear? Steps of construction here. Sometime I will write here, otherwise how I am going to explain step by step, listen it and try to write the steps by yourself. Okay? Next question. Question number 7. From your worksheet, question number 7. I hope everybody has attended 1 to 5 questions. This is regarding question number 7. Here we have to construct a tangent to a concentric circle, the point which is outside the circle to the inner circle. And also we have to verify it by actual calculation. Very, very important, most repeated problem. It is a textbook question. I will read the question once again. Question number 7. Construct a tangent to a circle of radius 4 centimeter from a point on the concentric circle of radius 6 centimeter and measure it. Verify by actual calculation. So first, let us draw two concentric circles. What are concentric circles? Circles with same center, different radius. So now with 4 centimeter and 6 centimeter, let us draw two circles. 4 centimeter circle and 6 centimeter circle. Draw two concentric circles, one with 6 centimeter radius, another with 4 centimeter radius. Is clear? So inner circle has a radius 4 centimeter, outer circle has radius 6 centimeter. So now take a point P outside the circle. Anyway, so I will take here. Now join OP. Anywhere on the circumference of the outer circle you can take, join O to P. First step, draw two concentric circles of radius 4 centimeter and 6 centimeter with center O. Second step, take a point P outside the circle and join OP. Third point, draw the perpendicular bisector to OP. Let us draw the perpendicular bisector. How to draw? Taking more than half, cutting on. This dot should be very light. Don't highlight this. Very smooth and light here. Okay? Because just to obtain the midpoint we are doing this. Just perpendicular bisector. Now join it. You will get a bisector of OP. So that midpoint of OP we got it. So now with MS center, MO as radius, draw circle which is intersecting the given circle at a distinct point. So after getting the dotted circle, mark the point where the dotted circle intersect the inner circle. Now join OA, it is PA and PB. This is always perpendicular. Okay? Is it clear? I will show you the rough sketch again. Draw two concentric circles like this with radius 4 centimeter and 3 centimeter. Take a point P outside the circle, join it. Draw the perpendicular bisector at point M, it will intersect. With MS center, MO as radius, draw a dotted circle intersecting the given circle at A and B. Now join PA and PB, measure it. That measurement you should get by actual calculation. Actual calculation, since it is a right angle triangle where OA equals 4 centimeter, OP equals 6 centimeter, PA, the length of the tangent we have to calculate. Where PA is the altitude, this is hypotenuse, this is base. So according to Pythagoras, OP square equals OA square plus PA square. That is 6 square minus 4 square equals PA square. PA equals root of 36 minus 16. It is root of 20. 4 5s are, it is 2 root 5. Where root 5 has the value 2 into 2.3. So the measurement of the tangent should be 4.6. Check it whether you will get 4.6 for the length of the tangent. Check it. After the construction, this is the verification. By using Pythagoras theorem, we verified. Okay? Pythagoras theorem, this will be the hypotenuse, base and altitude. Because we consider OA perpendicular to PA according to the property, so that by actual calculation the length will be 4.6. By measurement also you should get 4.6. Have you all got the answer? 4.6. Okay, now complete it. Below the construction, show the actual calculation and also try to write up the steps of construction, how I explained while constructing this. Come on. Over. Shall I move on to the next question? Have you all completed? Those who are completed, try to write the steps also. Over. This is regular construction. This I done as a practice for you people. Later you have to verify by actual calculation by using Pythagoras theorem. Next question. Question number 8. First I will show you the rough sketch. Draw a line segment AB of length 8 centimeter. This is rough sketch I am showing. Draw a line segment AB of length 8 centimeter. Taking A as center, draw a circle of radius. Taking A as center, draw a circle of radius 4 centimeter. Taking B as center, draw a circle of radius 3 centimeter. From A to B, if I take like this, okay, you will get a circle like this. This is 4 centimeter radius and this is 3 centimeter radius. Rough sketch I am doing. After drawing, you have to construct the triangular circle. That means to the line segment AB, draw the perpendicular bisector. It will enter the point M. Now with M as center, AB as radius, draw a dotted circle intersecting the circle in 4 distinct points. Name it as P, Q, R and S. That is, after constructing the perpendicular bisector to AB, what the midpoint M with M as center, M as radius, draw a circle intersecting the 2 circles at 4 points. Now join AP, AQ, BR and BS. You will get AP equals AQ 1 measurement and BR equals BS another measurement. This is the rough sketch I have shown. So now let us come to the regular construction. What is the first step? Draw a line segment AB of length 8 centimeter. Using scale and pencil, first step is draw the line segment AB equals 8 centimeter. So now with 4 centimeter one circle and with 3 centimeter another circle. It's okay. So now taking 4 centimeter, draw a circle . Okay, this is with center A. Next, with center B, you have to draw another circle with 3 centimeter. 3 centimeter radius, draw another circle. Name the second center as B. After drawing AB line segment with A as center, 4 centimeter radius, draw a circle. With B as center, 3 centimeter radius, draw another circle. Okay. Now we have to draw the perpendicular bisector to AB. We know how to draw the perpendicular bisector. Taking more than half of AB, draw arcs on either side like this. With same radius, cut off the former arc. You will get a perpendicular bisector to AB intersecting AB at point M. So use this dotted perpendicular line. Don't go with the straight line because we have to highlight the main construction. The perpendicular bisector is touching the circle at a point M. Okay, that is the midpoint of AB. 4 plus 4, 8 centimeters. So exactly it is touching the circle. Now with M as center, MA as radius, draw a circle which is intersecting the given circle at so highlight this intersected point here, P, Q, R and S. Okay. So now join first AP and AQ. Join AP and AQ. Measure what is AP equals AQ. Okay. Then join BR and BS. BR and BS. Again write its measurement. Both pair has the same measurement. If it is 6.2, then AP should be 6.2, like that. You should get the pair of tangents with equal measurement. Check it and give me your answer. Yes, you all got. Then I will proceed to the next question. Once again I will explain. If you draw the dotted circle, that will beautify your construction. If you are so lazy to do that, better to go with the 4 arcs. What I am telling here, in order to beautify, you have to do the construction. Okay? Don't go always the shortcut method. Write the measurement and check it whether the pair of tangents have equal length. Write the measurements below the construction. Write the measurement below the construction. If it is okay, then I will move on to the next question. Once again, I will explain the steps. Step 1. Draw a line segment AB of length 8 cm. Step 2. With A as center, radius equal to 4 cm, draw a circle. Step 3. With B as center, radius equal to 3 cm, draw another circle. Step 4. Construct the perpendicular bisector to the line segment AB. Construct the perpendicular bisector to the line segment AB intersecting at a point M. Next, with M as center, MA or MB as radius, draw a dotted circle or just mark the intersecting point. Instead of that, better go with dotted circle. Clearly we can show where exactly the circle is intersecting the two given circles. Let it intersecting the circle at P, Q, R and S. Next step, join AP, AQ, measure it. Next step, join BR, BS, measure it. They are the required pair of tangents to the circle. Yes, it should be 7.57. If it is having the same measure for the each pair, your construction is correct. Good. Okay now? Shall I move on to the next question? Here, question number 9. Construct a pair of tangent to a circle without using center. For a construction of pair of tangent, we used to have circle from the center, getting a point outside the circle, we used to construct the pair of tangent. But here the question is, without using the center, we have to construct a pair of tangents. Okay? Shall we move on to question number 9? I just underlined it, so you should not confuse. It is a tangent or a pair of tangent. That is the reason I underlined those two parts in question number 9 and question number 10. Now question number 9, I will show you how to do this. Alternate method is also there. That we will do when we have the regular classes. The common method where the textbook is given the clue or hint, to that type today I will go. Okay na? Listen the explanation for the rough diagram. Then we can go back to our regular construction. Good? Yes. So here without using center is given, but though we are not using the center, but for the circle we use the compass. Otherwise, if you have any circular object, draw a circle of any radius. Draw a circle of any radius using any circular object. Okay. After that, because we are not getting the center, to that we have to get a circle with any circular object, for example bangle. Okay. Then take three non-collinear points P, Q and R. In the last class, that is in 9th standard, you all understood and you have constructed a center to the circle. Here also the step is how to locate a center, how to find a center to the circle. Join PQ, join QR, draw the perpendicular bisector, let it intersect, you will get the center of the circle. Now here we have to go with the procedure how we used to construct a pair of tangent using center from here onwards. After locating the center of the circle, take a point P outside it. Now draw the perpendicular bisector. You will get a point. Now construct a dotted circle intersecting the circle at PQ already mentioned. So take a point A, name N and N, join AM and AN. That is construction of pair of tangents without using center. Later we locate the center by the construction part. In the question dimension, when the circle is drawn using any circular object, how to construct a pair of tangent. To that, we located the center of the circle by taking three non-collinear points and obtained the center of the circle by drawing the perpendicular bisector. Then taken any point A outside the circle, joining O to A, drawing the perpendicular bisector. From the midpoint, if you draw a dotted circle, that will intersect the circle in two distinct points, M and N. Join AM, join AN. They are the pair of tangents. This is how we do. Okay, na? Shall we go with the instrument construction? Now, draw a circle of any radius. There is no restriction because we are not considering the compass as a circle. Draw a circle of any radius. Okay. Now, take any three non-collinear points P, Q and R. Join them in order, that is P to Q, Q to R. After drawing P to Q, Q to R, we have to construct the perpendicular bisector, taking more than half, drawing the arc. These are all very light feather touch construction. Okay, just to locate the center we are using. So just make a feather touch arc like this. Okay, now after getting the perpendicular bisector for PQ, then go with the bisector of QR, same type, to the point Q, taking more than half, drawing arcs on both the sides with same radius, cut off the former arc. Okay, cut off the former arc. Now join, so that will be the point of intersection of the bisector will be the center of the circle. We have located the center of the circle. After the location, take a point P anywhere outside the circle. Now we have to draw the pair of tangents. To that, the procedure what we are used to follow for the pair of tangent construction, same thing here also. Taking more than half, draw arcs on either side, cut off the former arc with the same radius. Okay, so we got the perpendicular bisector. Now to the segment OA, draw a dotted line like this. It will intersect at a point D, let us take. Now with the D as center, DO or DA as radius, draw a circle or you can intersect the circle. It is left to your interest. I am not forcing. If you do this, that will be a clear picture of the location of the center. Okay. As M and N. This is M and here it is N. Join A to M and A to N. Measure it. So it will differ because we have not taken the specific radius. It is depending on your radius. the pair of tangent measures differ. So write up your own measurements below the construction, like AM equals AN equals in centimeter. Come on. After constructing, measure the tangents. Have you all got the measurements? Yes? You got the same measurement, Vishal? You got the same measurement? Below the construction, write up. Okay? Manya, Mrunal. So just write up the measurement what you got. Okay? Pranjal. I will move on to the next question. Question number 10. Construct a tangent. This tangent construction is not in your textbook portion. I just added it because you may get as a 2-mark question of this. Okay, na? Vaishnav? So now, construct a tangent to a circle without using center. Here also we follow one of the property of the circle, that is angles in alternate segment are equal. Based on that, this question. Okay. Now using your compass, draw a circle of any radius. Come on. Using your compass, draw a circle of any radius. Have you all drawn? I'll show you. This is not in your syllabus. Still, a tangent using center, without using center, both the type here I am covering as a expected question. Okay. So with any radius, the circle is ready. Next step is draw a chord. You know what is chord? Draw a chord AB. Take a point P in the major segment. Join AP and BP. Okay. First step, draw a circle of radius. If it is given, you have to go with that measurement. Then draw a chord AB. This chord AB divides the circle into 2 segments. Major segment, minor segment. To the major segment, take a point P and join AP and BP. And here the property, angles in alternate segments are equal if you draw a line passing through the point of contact here. So conversely, if you show the angles are equal, the line which passes through is the center, is a tangent to a circle. In the beginning only we have constructed a tangent at a point P. Here, without using center, we have to construct a point. So that means from here with the convenient radius, draw an arc. Okay? That is, we are showing the equal angles at point P and angle A. Okay? Here I constructed, here also same radius. Take this width, cut off this width here. This width you have to cut off. Now passing through that intersected arc, if you draw a line, that will be the tangent. T dash A, T is a tangent. In the circle chapter, I am going to prove how angles in alternate segments are equal. It is a property. That is, if a tangent is drawn to the point of contact of this A chord, then the angles so formed are equal. Conversely, if the angles in alternate segments are equal, the line which passes through that point must be a tangent. Using that, so I will show you once again. Draw a circle of any radius. Draw a chord AB. Take a point P on the major segment. Join AP and BP. Now construct an angle APT such that angle BAT should be equal to angle APB. So that what I did with the convenient radius here, I took an arc like this. Okay. Any arc, same arc here also I produced. And take this width I have cut off here. Okay, clear? You will get an angle which is equal to this angle, so that the line passing through that part must be a tangent. This is how we construct a tangent without using center. Using center, yesterday only explained. You have to take a point P on the circumference, joining OP, drawing the perpendicular line at P, then that line will be the tangent to a circle. Okay? Now, question number 11, yesterday only I think I have done. Anyhow, we will do now. Draw a circle, take a point and then extend a diameter at a distance of 7 centimeter. Last construction, yesterday's last construction. Okay, and from the point you have to draw the pair of tangents, measure it and given. So if you are constructed, we'll go on to question number 11. You are constructed a tangent, a pair of tangent without using center, a tangent without using center. A pair of tangent without using center is in your textbook part. This is apart from the textbook part. Okay? And move on to question number 11. This you already done. Again we will do this. Question number 11. Draw a circle of radius 3 centimeter. Draw a circle of radius 3 centimeter and take a point P and Q on one of the extended diameter, that is passing through this point. Yesterday I did, again because of the continuation I am showing. 7 centimeter from here, 7 centimeter. Name the point as P and Q. First, draw a circle of radius 3 centimeter. Take 2 points P and Q on the one of the extended diameter. Now, draw the perpendicular bisector to OP, taking more than half, cutting arcs on both the sides. With the same radius, cut off the former arc. You will get a dotted line. Now this is the midpoint, name it as M. Now with M as center, MP as radius, draw a dotted circle like this. This dotted circle intersecting the given circle at A and B. Join PA, P. Same thing to other part. That is, again construct the perpendicular bisector. Okay, now from the midpoint, draw a dotted circle intersecting the inner circle again in two distinct points, that is C and D. And C and D. Join QC, join QD. Measure each pair. You will get 49 minus 9, root 40, that is 2 root 10, 6.6. What measurement you got it? Pair of tangent measurement. Is that 6.6 centimeter? .7 7 centimeter 49 minus root 3. 3 square is 9. 49 minus 9 is 40. So you should get 6.3 approximately. Check out once again, it's not 5.7. In both the side, you should get PA equals PB, 6.3 or 6.4, okay. Same QC equals QD is also 6.3 centimeter. Point error, okay. Okay. You will get exactly 6.3. Chinmaya is right. 6.5 is, you should not consider not more than plus or minus 0.1. Check it once again, Sahana. Okay. Now I go with question number 12. I will give the explanation here. This is like in the beginning what I did for question number 6. When it has an inclination of 60 degree, we constructed at the end, at the center 120 degree. Here the inclination is 35 degree, 135 degree. No, actually it's not 135 degree, it should be 45 degree. Please do the correction. Question number 12. You should construct at center 135 degree. How to do 135 degree? 120, 150 between, you have to bisect it. Or you can make use of the protractor for the correct fact. Okay. Now the question. First, draw a circle of radius 3.5 centimeter. Draw a circle of radius 3.5 centimeter. Please do the correction. It is not 135. It should be 45. The angle should be 45. At the center, you have to construct 135. Okay. So make an imaginary line here with center O. You have to construct 135 degree. 135 degree, 105 degree, 75 degree, all these constructions you have done in 9th standard. Same repetition here. If you draw a semicircle like this, it will be 60, then 120, and then it is 180. In between 120 and 180 you bisect, you will get 150 degree. Here you will get 150 degree, but we require 135 degree. So after constructing 120, 180, in between 30 degree, further you bisect it. Suppose if you find difficult, make use of your compass, then you can use up your protractor with the compass. Okay, this is 135 degree line. Name it as point A and B. Is it clear how to construct 135? Semicircle, one arc 60, double arc 120. Between 120 to 180, if you bisect, you will get 150. Again 150 to 120, further bisect, you will get 15 degree plus 120, it is 135. Now on the extreme end, construct perpendiculars here at B. /90 line. Now again at point A, construct another 90 degree here perpendicular line. You can check with your protractor also for your verification. Suppose any deviation with arc, you won't get exactly 45 degree at point P. Okay. So now passing through that intersected arc, if you draw a line that will be intersecting the previous line at P, having the inclination of 45 degree, it is the inclination of 135 degree. 45 degree plus 135 degree is 180 degree. Sum of the angles bounded by these two is always supplementary. We are going to prove that in circle chapter. Here practically I am showing, if I construct 135 degree, you will get 45 degree. Okay. So in the previous question number 6, what we did, we construct 120 degree at the end, So we got the inclination 60 degree. That is satisfying. The sum of the angles bounded by these two is always supplementary. That is the reason we can get. Now measure the tangent PA and PB. You should get equal measurement. Check it and write the measurement below the construction. Below the construction, write the measurement. What is the measurement? 6.4 centimeter. Okay. Who is Pramila Manohar? Please name of the student. Name of the student. Okay. Okay. Good. And those who are submitted your assignment, please come here and take the assignment, corrected assignment. And I don't want any other assignment. Okay. Again, next time when I inform, you can submit it. Not now. Those who are already given, please come and take up your assignments. Tomorrow's class, yes, okay. Tomorrow's class, I will do construction of similar triangles. That is another part. So far we did line bisection and problems based on the tangents. Now construction of similar triangles. To that we have separate worksheet that completes your geometrical construction. My request, while doing the assignment for each construction, briefly write the steps of construction and please note down the name and the measurements. You have to give up the measurements completely with detail, unruled sheet if it is, unruled book if it is notes. Complete the construction along with the steps of construction. Okay, we'll do specific type of triangle construction, similar triangles. Similarity of the triangles, what we are going to study in similar triangles, that is on the construction part. We'll do that in tomorrow's class. Thank you, children.